This is our sample trial question that we are supposed to work on. It is a compound PDF and they want us to generate its CDF. So I'll be giving the initial steps and the class you have to complete it in your free time, definitely using the procedures which we used yesterday. So they are saying that the random variable x has a PDF given by that, and required is to find the CDF capital F of x and also sketch it. Normally one part they want us to get the median and also that probability. So yesterday we said that whenever you meet a question of this kind and it wants the CDF from the PDF, you first of all draw a number line and put all the values that are indicated on the intervals in the PDF. So this is our PDF. We shall draw a number line like this. The first value beginning from the list. So the list is a 0, put here is 0. The second one is a 2. After 2 we have a 3 and they are over. So for this region before 0, we shall look for all x values which are less or equal to 0. For the region between 0 and 2, we need values which are between 0 and 2. 0 less x less 2. Then we shall have 2 less x less 3. Then we shall have x greater or equal to 3. After drawing the number line, you redefine the PDF given in terms of t, but you first let f of x to be f of t. So I will let my f of x to be f of t. After letting f of x to be f of t, we say if you want capital F of the first one, you must have the capital F of x of the second one, and you substitute with 0 to get this one. If you want the capital F of x of the last one, you must have capital F of x of this, and you substitute it with 3, you get the capital F of x of the last one. Now after letting f of x to be f of t, you now rewrite this, but this time in terms of a t. So our f of t is going to be, it is t over 3, that is when t is between 0 and 3. It is negative 2 over 3 t plus 2, that is when t is between 0 and 3, and it is 0 elsewhere. So after redefining it, then you now go interval by interval. So we are going to begin with this one. Because to get this, we must have this. Now in our, of course this is our solution. To get this, we must have this. So we are beginning with the interval for 0, 0 is equal to x, this is equal to 2. After that, we said yesterday that capital F of x, after redefining f of x in terms of f of t, is an integral from negative infinity to x of f of t dt. Now my first f of t now substitute this lower limit in the capital F of this and you get the capital F of this one. So, if we want the capital F of x for the first interval, our first interval is x should be less or equal to 0. So for x is less or equal to 0, our capital F of x for the second interval is already x squared over 6. So you get the 0, this is 0, and you substitute in there to be 0 squared over 6. And capital F of 0 is 0. So my capital F of x becomes 0 for all x values less or equal to 0. After getting for, when you get for this, now you can get for this. So if you want for this one, you go back to the redefined PDF. We are now on for 2 is less or equal to x, less or equal to 3. You recall that our f of t was a t over 3. This is when t runs from 0 to a 2. It was a negative 2 over 3t plus 2. This is when t runs from 2 to 3 and it is 0 elsewhere. We now want to get the capital F of x of this one. But you realize that you cannot get this interval unless when you have passed through the first one. You can't get the second one unless when you go through the first one, because we are dealing with continuous random variables. So our capital F of x, we say it is given by negative infinity to x, f of t dt. This is the f of t that we are supposed to integrate and get capital F of x. So my capital F of x now becomes, where there is negative infinity, I put the lower limit, which is from 0 to 2. We have not reached this one which we are interested in. When you reach there, you integrate from 2 up to x, not up to this one. So from 0 to 2, but it is t over 3 dt plus the integral from 2 up to x, because our interest is in this one. If your interest is in the first one, you integrate from 0 to x, you don't reach this. When you go to this, because they are continuous, you consider the first one and also the second one. But the integral for the second one runs from 2 up to x, but of negative 2 over 3t plus 2 dt. So we shall then have a 1 over 3, the integral from 0 up to 2 of t dt plus the integral from 2 to x of negative 2t over 3 plus 2 dt. We are now substituting in. We are going to have 1 over 3. This is a t squared over 2 from 0 to x plus this is a negative 2t squared over 6. You increase the power by 1 and divide by the new power plus a 2t, but we have integrated from a 2 up to x. This is from Now, having found capital F of x of this, capital F of x of this, capital F of x of this, and of the other one, we can now write it as a whole. So our capital F of x is now going to become, this is 0 for all of x values less or equal to 0. This is x squared over 6 for all of x values between 0 and 2. It is a 2x minus x squared over 3 minus 2 for all of x values between 2 and 3, and it is a 1 for all of x values greater than equal to 3. So that would be our CDF, capital F of x. So after finding capital F of x, they are telling us that we use that capital F of x. We need to sketch our capital F of x. So this was find the CDF capital F of x and sketch it. Yeah, we need to sketch our capital F of x. Now for a sketch, we say you state an interval at a time, and then you deal with it. This is now for the sketch of capital F of x. You begin with the first interval, and you say for x is less or equal to 0, capital F of x is equal to 0, which is a linear line, which is a straight line, because capital F of x is equal to a constant. You go for the second one. So for the next interval, why we have just said it's linear? Because we have only one any x value. So we shall only consider x values up to this, and we draw a straight line until when we reach that x coordinate 0. So for 0 is equal to x less or equal to 2, our capital F of x is equal to x squared over 6. So this is when x runs from 0 to 2. Now our capital F of x is equal to x squared over 6 concordance says capital F of x is equal to 0, it's less than a half, therefore x is less or equal to 0, is not the median interval. Then you go for this one. Capital F of x is equal to x squared over 2. Capital F of x is equal to x squared over 6 for the interval from 0 to 2. You put in the upper limit, you also put in the lower limit, and you subtract them. And when you substitute them clearly, you will realize that it is going to become a 4 over 6, which is the same as 2 over 3, and 2 over 3 is greater than a half. So since 2 over 3 is greater than a half, it means the median interval is this. Therefore, small m lies here, and capital F of m is going to be a half. So you put here m squared over 6 and equate to a half. And if you do that, realize that the median is 1.7321. After doing that, you will go for Roman 2, which is to do with the finding the probability 1 is less x less to 0.5. Yesterday we said when they give you a probability of that nature, is a probability 1 is less x less to 0.5. So you get capital F of the last value, which is a 2.5, minus the capital F of the first value, which is a 1. So our capital F of 2.5, you go here and you place where 2.5 lies. So 2.5 lies between 2 and 3, it is here. You get that 2.5 and put it in this function. So it will become a 2 into 2.5 minus a 2.5 squared over 3 minus a 2. Now that whole thing is going to be minus the capital F of 1. 1 lies between 0 and 2. So here there is x, you put a 1. We shall have 1 squared over 6. And if you do that, you realize that the answer for the probability 1 is less x less to 0.5 will be 3/4. So your responsibility then is to go slowly and confirm that these answers are actually very correct. Yeah, so that is that about Roman 2. Now the other note which we had was that given the CDF, the other note which we can make here is note given a CDF, capital F of x, comma, the PDF, small f of x, can be obtained through differentiation. Underline that. We shall have example on that after confirming that people have been able to use the knowledge which we used yesterday to do this thing. We shall now have a basis to extend to this note. Thank you for listening. Make sure that you follow up all the videos which were posted on YouTube so that you do not